Imagine packing your bags for a quick 8-day work trip, only to find out you're going to be stuck there for 8 months. Sounds like a nightmare, right? Well, that is exactly the stunning reality currently facing NASA astronauts Commander Barry Wilmore and pilot Sunita Williams. Back on June 5, 2024, they launched on the Boeing crew flight test. This was supposed to be the big one, a mission designed as the final hurdle to absolutely prove the capabilities of Boeing's new Starliner spacecraft. It was meant to be a short, straightforward trip up to the International Space Station and back. But instead, it has become one of the most high-profile aerospace dramas in recent history. Welcome to this Explainer, where we're going to break down the anatomy of this mission, how it went so wrong, and what it all means for the future of space exploration.
Okay, let's dive into this. If you've glanced at the news lately, you've probably seen some highly sensationalized headlines out there claiming these two astronauts are desperately trapped in the dark void of space. So let's look at the facts. They are absolutely stuck, yes. Their ride home is fundamentally compromised. But are they in immediate danger? The short answer, absolutely not. We are talking about two incredibly seasoned professionals here. Commander Wilmore had already logged 178 days in space before this launch, and Sunita Williams, who is a highly experienced veteran, had spent 322 days in space over multiple previous expeditions. They are safe, they are exceptionally well-trained, and they are exactly where they know how to survive.
To really understand why they're safe, you have to realize they aren't just cramped inside some tiny metal tin can. The International Space Station is a massive, 350-foot technological marvel. It actually boasts more living and working space than a 6-bedroom house. It is fully equipped with incredibly robust life support systems. For instance, it actively generates oxygen through the electrolysis of water and expertly recycles the carbon dioxide they exhale. The station even captures moisture from breath and sweat, and yes, it literally recycles urine right back into perfectly safe drinking water. Add in a 6-month food reserve, 2 bathrooms, a gym, and a spectacular 360-degree bay window, and you can see that while they might really be missing home, their basic survival needs are more than covered.
And they aren't just sitting by that big window waiting around for a space taxi either. Barry and Sunita are actively integrated right into the daily operations of the ISS. They are working shoulder to shoulder with astronauts from NASA and the Russian space agency Roscosmos as part of Expeditions 71 and 72. They're keeping super busy by conducting vital research on space botany, literally studying how flowers can be grown in microgravity. They're also researching space-caused fluid shifts in the human body and testing algae-based life support systems. So they are actively contributing to critical scientific advancements while they wait for a ride.
Section 1. The technical challenge of orbital spaceflight.
Building a spacecraft to carry humans is incredibly difficult. In fact, historically, only 3 countries on Earth have ever achieved human orbital flight: Russia, the United States, and China. Why? Because the physics are totally unforgiving. And this brilliantly illustrates the point. Think about a suborbital craft, one that basically just touches the edge of space for a few minutes of weightlessness before falling back down. That requires speeds of just under 7,000 kilometers per hour. But an orbital spacecraft like the Starliner, that requires a staggering velocity of over 28,000 kilometers per hour just to lock into Earth's orbit. The engineering precision, the intense heat shielding, and the massive propulsion systems needed to survive this kind of kinetic energy are just mind-boggling. There is virtually no margin for error.
Section 2. Anatomy of a failure.
So how does an aerospace titan with a multi-billion-dollar budget end up here? Well, the problems didn't start in the vacuum of space. They actually started right down on the launch pad. On May 6th, just 2 hours before liftoff, the launch was totally scrubbed due to a faulty pressure valve on the rocket. Then on June 1st, a computer abort system suddenly halted the countdown with only 4 minutes left on the clock. Finally, on June 5th, they managed to launch, but engineers had already detected a helium leak caused by a defective seal. Now, at the time, they deemed this leak quote-unquote manageable. But what this timeline reveals is a serious series of cascading, cumulative issues rather than just one single isolated glitch.
4. By the time the Boeing Starliner finally docked with the International Space Station, the crew had discovered not 1, but 4 separate helium leaks. That manageable problem on the ground had multiplied significantly under the immense stress of orbital flight.
The true gravity of the situation became undeniably clear when Boeing's commercial crew program manager admitted flatly, "We don't know what the problem is. We need to first understand the root cause." This is a massive, massive issue because helium isn't just some incidental gas up there. It is absolutely critical for pressurizing the propulsion system and firing the spacecraft's thrusters. Simply put, without reliable helium pressure, you cannot reliably steer the ship.
And that loss of steering became a very real, very scary crisis just hours before docking. The data showed that 5 out of the 28 thrusters on the Starliner failed entirely during the delicate approach to the space station. Imagine trying to parallel park, but your steering wheel just gives out. Commander Barry Wilmore had to take manual control of the spacecraft. Working frantically with engineers on the ground, he managed to reset the thrusters, eventually coaxing 4 of those 5 back to life to complete a successful, albeit terrifyingly nerve-wracking docking.
So the crucial point is, what actually killed those thrusters when the astronauts needed them most? During hot fire tests conducted later by NASA and Boeing engineers, a clear mechanical breakdown was mapped out. First, as the capsule was exposed to intense, direct sunlight in orbit, it caused substantial overheating in the manual control system. This thermal stress directly led to the thrusters malfunctioning and shutting down. When they tested it without the sunlight, sure, they worked fine, but engineers simply couldn't guarantee that the overheating wouldn't happen again during the absolutely critical, fiery re-entry into Earth's atmosphere.
Section 3. SpaceX to the rescue.
Faced with unpredictable hardware, NASA firmly prioritized safety over good PR. They refused to risk a repeat of the devastating 2003 Space Shuttle Challenger disaster that tragically claimed the life of astronaut Kalpana Chawla and her crewmates. The risk of flying Starliner back with the crew was simply too high. Now, what's really interesting about this slide is the profound financial irony of NASA's solution. Back in 2014, when NASA awarded contracts for the Commercial Crew Program, Boeing was handed a staggering $4.2 billion, while a relatively new competitor named SpaceX received $2.6 billion. Boeing was supposed to be the safe, reliable legacy choice. Fast forward to today, and Boeing's heavily funded spacecraft is returning to Earth completely uncrewed, and NASA is relying on SpaceX to step in and finish the job.
The logistics of this rescue mission are just fascinating. In February 2025, SpaceX's scheduled Crew 9 mission will launch, but instead of its usual 4-person crew, it's going to launch with only 2. This cleverly leaves 2 empty seats for Sunita and Barry, allowing them to finally hitch a ride home. Honestly, it highlights just how unbelievably far ahead SpaceX has leaped. I mean, while Boeing is struggling with basic thruster functionality, SpaceX is successfully executing regular crewed missions and is even preparing to conduct the world's first private spacewalk.
Section 4. Boeing's systemic crisis. Viewing this Starliner situation as just a bad day in space really misses the terrifyingly large picture. This isn't just an isolated spacecraft issue. It actually reflects a broader, darker pattern of engineering and manufacturing oversights across the entire aerospace giant. Let's move to and see how this builds across Boeing's commercial aviation division, which has been rocked by deadly and catastrophic failures involving their 737 MAX airplanes over the last few years. In 2018, Lion Air Flight 610 crashed. Just months later, in 2019, Ethiopian Airlines Flight 302 suffered the exact same tragic fate. And just this year, in January 2024, an Alaska Airlines 737 MAX had a door plug completely blow out at 16,000 feet, causing a rapid, horrifying decompression.
When you really look at the root causes of these terrestrial failures, a chilling pattern emerges. The crashes in 2018 and 2019 were caused by faulty sensors feeding bad data to glitchy override software that physically fought the pilots for control of the plane. And that 2024 door blowout? That was caused by loose hardware and literally missing bolts straight off the factory floor. These are fundamental failures of quality control, carelessness, and systemic engineering oversight. It is a massive, company-wide culture issue that has culminated in the current CEO announcing he will officially step down by the end of the year.
Which leaves us with this final, vital question as we wrap up today's explainer. When you look at the faulty valves, the software aborts, the helium leaks, and the overheating thrusters on the Starliner, and then you place them right next to the missing bolts and glitchy software on commercial airliners down here on Earth, is this really just an isolated spacecraft glitch, or are we witnessing the ultimate symptom of a massive corporate breakdown at one of the world's most historic aerospace companies? It is a heavy question, but it's one Boeing is absolutely going to have to answer before they ever put human lives on top of one of their rockets again. Thanks for joining me for this explainer, and remember to keep questioning what's going on behind the scenes of our biggest technological leaps.